Welcome to CK Physics. The topic we're dealing with is waves, and I have a number of operators here that I'm going to use to demonstrate waves. I have a mass and stream, I have a mass and spin, I have a ruler, and I have a slinky spin. I would like first for us to understand that a wave is an oscillation or a vibration, and perhaps we start by understanding the distinction there. If I use this ruler and I have part of it fixed and I click one side, it is able to move up and down. Part of it is moving about its fixed section. When part of an object moves to and fro about its fixed section, then we say this object is vibrating. Unlike a case where I have a mass and a strain system, where I could hold that mass at a fixed point and I make it to move to and fro. In a case like that, the mass is said to be oscillating because the whole object is moving to and fro. So let's get the distinction clear. If part of an object is moving about its fixed section, that is a vibration. If the whole object is moving to and fro about a fixed section, that is an oscillation. And perhaps I could illustrate further the idea of an oscillation using a mass and spin system. If I hold this mass stationary at that point, we say it is in an equilibrium position. Then if I displace a little bit, it begins moving to and fro about a fixed section. So in this case, the mass is oscillating. Perhaps I could move on from here and then argue that when you think of a wave, where we're transferring energy because of an oscillation or a vibration, we can do so in two possible ways. We can do so using transverse waves, or we can do so using longitudinal waves. What I have here is a slinky spin. The slinky spin will help me to illustrate the two types of waves. So if you think of a slinky spin, along there, that is said to be its axis. If I have a to and fro motion of one of my hands perpendicularly to the axis of the spring. Remember, axis of the spring, that will be a 90-degree vibration, to and fro motion. Then the kind of wave that I generate here is known as a transverse wave. Transverse waves are those waves which transfer energy perpendicularly to the direction of vibration. From my right hand, we are moving to and fro in a perpendicular direction to the axis. I'm able to generate energy which moves to my left hand, and therefore we think of energy transfer being perpendicular to the direction of vibration. However, I could also generate another type of wave where I move the right hand to and fro along the axis of the wave. The kind of wave I'll generate is known as a longitudinal wave, in which case we have regions where particles are close together and we have regions where particles are spaced out. So if we try this one more time, here we are. The kind of wave I'm generating is a longitudinal wave. The regions where particles are closely packed together are known as compressions. The regions where particles are widely spaced out are known as rarefactions. So of all waves that we know of, the only main type of longitudinal wave is sound wave. We do have the primary waves during earthquakes, but think of it as sound waves, and whatever the frequency of sound waves, whether it's ultrasound or infrasound, it will still be a longitudinal wave. Otherwise, all other waves, whether it's water waves or light waves or X-rays or radio waves or microwaves, all those other types of waves are transverse waves. I hope the point is clear about generation of waves by vibrations, which could be either perpendicular to the direction of wave, in which case we have transverse waves, or parallel to the direction of the wave, in which case they're longitudinal waves. Thank you.